Alright, let's go over how to solve a problem like this, which reads, write a program that contains the following two functions. And we have a convert from our feet to meters function, which we give it the amount of feet, and it returns to us the equivalent amount of meters. And then we have another function or method here, convert from meters to feet, where we're going to pass to it the number of meters, and it will return to us the number of equivalent feet. Here are our conversion equations that we'll use inside of our functions. Then we're going to use these two functions to create a table in our program that looks like this. So we'll use a for loop to loop through and call this two functions over and over again to produce the rows in our table. And we can start to see the power of functions in being wrapped up reusable code. Alright, let's begin. We open up Eclipse, right-click on your project, and say New Class. Remember to name your classes with a capital letter. That's a Java standard. I'm going to name it Conversion, Meters, and Feet. Yes, that's a long name. Alright, click on public static void main string args so that it'll write this line of code for us. And we click Finish, and it creates our source file. Now remember to put your name at the top of your programs, and then put the date. It's always helpful. Then you can put a little bit about what you're writing. This was our programming problem, conversion feet to meters. Oops. Alright, so later on we're going to write our algorithm all the way out, but let's think about the beginning of our algorithm. The input to our program will be either the meters, if they want to do a meters conversion, or feet, if we'd like to do a feet conversion. So our input will be our meters and our feet. Our output will then be the converted meters and feet. So we can say our meters and feet, and then our output will be our converted meters and feet in a table format. All right. Now I know many textbooks and maybe many instructors will say that you have to write your algorithm first. And it is good to think about your algorithm. But I've learned over the years of teaching a level 1 programming course that this rarely happens. Many students will start to program. Now when they start to program, they are indeed writing the algorithm. They're doing it sort of in their head. So I think this is still an acceptable practice when we begin programming, to write the algorithm as we start to write our program. So we'll write our formal algorithm after we've written our program. Alright, so let's write this function feet to meters, where we pass to it the feet and we return the meters. So we're going to start our method off with public static. Now think about what it wants to return. It wants to return the converted meters. So this converted meters might have a decimal place. So our return type should of course be double. Plus they told us that. Now let's write the name of our method that always comes next after the return type. And this will be feet to meters. Alright. Remember that you can name your function whatever you want to name it, but you should always name it with a lowercase letter. Now think about what we need to pass into this function so that it will convert our feet to meters. It has to know how much feet we want to convert. So that of course makes sense that that should be our parameter. Plus they told us this. Alright. I'm going to write this function a little bit longer so that we'll totally understand what's going on in here. we're going to make a new variable called double meters, and we're going to assign it the value of our converted feet. So we just need to translate our equation here, our converted meters. Our equation here will be 0.305 times the number of feet that we're passing in. So we'll have 305 times the number of feet that we're passing into this function. Then we're going to return that amount of meters back to our program, because that's what it's asking for. Alright, now let's test that this function is working. It's always good to test as you go. Alright, this function is going to return to us the amount of meters. Note that I can create a new variable and declare it meters because this variable is only alive inside of this function. Remember that that's called locality of variables. Okay, so meters will get destroyed at the end of this function, and his value is passed back to where we've called the function, but the actual variable inside of main memory is no longer used by this program. Alright, so I can declare a new meters variable here in main. It's totally different than that variable, and I can call this function feet to meters. You can always think of a function as what it returns. This function will return a double, so that's why I can assign a double variable to what this function returns. Now I'm going to pass to it an argument that will be copied to this parameter feet. So it's asking for a double. So I need to pass to this function a double amount of feet. I'm going to do 1.0 because in my programming problem I can see that 1.0 should return 0.305 feet. And then I'll test it with 10.0 and it should return this, 3.050. So let's test it. And to see my results of these two tests, I'm just going to output what meters equals to the console, which is a good way to start out testing. So I'll print out meters after I call the method once. Triple click, Control C, click, Enter, Control V. And then I'll call system out print line again after I've called the method a second time, and this time giving it the input of 10.0. I'll run this code, and I can see that I do get the correct results. Of course, I'll need to format my output to the correct decimal places, but it is the correct results. Now, if you're having trouble understanding functions, don't feel bad. A lot of students do at first. It is a different concept than what we're used to thinking about. So to kind of help you understand functions, I'm going to show you how to use the debugger. So to use the debugger in your program, what you'll do is you have to create a breakpoint. All IDEs have a debugger as part of their tool set that you use to help fix your programs, especially as your programs start to get harder. Of course, this program is really simple, and you could probably debug it in your head. But with this problem, I'd like to show you how to use the debugger so that when your programs do get harder, it'll be easy. So, well, to debug them. Alright, so to use the debugger in Eclipse, just like any IDE, you have to put a breakpoint. Usually in lots of IDEs, what you do to put a breakpoint is to double-click over here in the margin. In Eclipse, breakpoints are represented with little blue balls. If you hover over the little blue ball, it says line breakpoint, and it shows that we're going to stop our program, or pause our program, not stop it, right here. And when we pause our program, we can then use the buttons inside of our tool to step through our program one line at a time. And when we do this, it'll help us figure out what's going on inside of our program so that we can see how our program is running. And also, if our program is not running correctly, we can look at the values of our variables as our program is running, and it'll help us fix or debug our program. Alright, to get the debugger to work, Then to activate our debugger, you'll go up to your toolbar and you'll hit the little bug button. Now, when the debugger gets to your line of code where the breakpoint is set, it'll tell you that it's going to launch the debug perspective. This will open up a bunch of windows that'll help us in debugging our program. So we'll say yes. It opens up our debug perspective. Now for us, our outlines is not going to help us, so we'll go ahead and close our outline. Also, inside of this class, we don't need to look at our stack of our method calls. Well, actually, maybe that would be helpful. We're going to look at our stack of method calls. Alright, so you can see here that we've paused our program at this line of code. Wherever the green is where your program is paused. It shows us our variables that are created in main memory at this point in our program. Since we've run this line of code already, you can see that the meters variable was created and set to the value 0.305. That's great. Alright, now let's step through our program. We're going to use the tools here at the top to step through our program. Every IDE and debugger has these same buttons that will allow you to step through your code. Now there's the step into and the step over, and they do just that. They step into your code or they step over a function call. Now I don't want to go into the printline function, so I'm going to step over, and you could see that the printline function was executed and it printed to the console. Now I'd like to step into this function call, my next line of code. So I'll hit the step into button or hit F5, and it takes me to where my program execution line of code is next. Note that now I'm inside of my function because it was my function call. Also note that the meters variable in main is not available here in main memory because inside of main, which you can see this function call is waiting. So the main function is in pause as we've given execution time to the feet to meters function now. Note that the feet variable has been created and is set to 10.0. This is our feet variable. He is available inside of our function because that's the variable we create when we call this function. Remember that he is created in memory as a new variable and set equal to what we pass as the parameter. The parameter is copied to this new variable, and when this function ends, this parameter is destroyed in main memory and no longer exists. And every time that we call this function, he is created anew inside of main memory. This is an important concept, and if you understand this concept, a lot of things in programming will be clear to you. This is called pass by value because we are copying the value of the argument to the parameter who is created on every function call. Alright, let's move on. We've created our meters variable inside of this line of code. So if I choose step over, you can see that this line of code was executed and that meters is set equal to the correct conversion. Now I'm going to execute my return statement, which returns this value meters back to our main program. Now watch as this function call is then popped off of the stack of execution stack and is no longer there, and these variables will be destroyed out of RAM. So I'll choose step over. It returns me to main memory, and all of that function call inside of my main memory is released and no longer there. Those variables are destroyed. But that variable that it returned, the variable value it returned, is saved inside of my variable inside of main called meters. So you can always think of your function call as what it returns. It returns 0.305, so that 0.305 is put into the variable meters. I can now print out that variable meters and see that value. Alright, now that we've debugged our program, to get back to the regular Java perspective, the interface that we're used to seeing, we just go up here to the upper right and click Java. This is our Java perspective. This is our debug perspective. Java perspective, debug perspective. So you can always switch between the two. If you're not debugging your program, it's more convenient to be in this perspective. Now that we've tested these two function calls, now that we've tested the feet to meters, let's go ahead and write our meters to feet. Now our meters to feet function is going to look very much like this function. So I'm going to go ahead and Control C and copy that, and then Control V and paste that. If you're on a Mac, of course, it's Command V and Command C. Now it's red underlined because I have two functions with the same name and same number and type of parameters, and Java doesn't allow that. So I need to rename this method, meters to feet. And I'm going to pass to it the amount of meters. Now it's still a red underline because it wants me to return a double. I promised that I would return a double in this function, so it's going to stay red underlined until I return a double. Now that's not really the double I want to return. I want to return a number of feet with this amount of meters passed into it. So I'm going to go look at that conversion function. And to get the number of feet, it is 3.279 times those meters. So I'm going to want to return 3.279 times our meters. Now note inside of this function, I didn't bother making a new variable. And this is more typical of how most programmers would write this conversion function. There's no need to have this extra variable created here when all I want to do is return this value. So you could actually just return that value and not store it inside of main memory. You just do the calculation and that value is returned to where you called that function. Alright, now I'm going to go ahead and test my second function here, meters to feet. So I'm going to go ahead and Control C my test, and Control V. I'm going to go ahead and make some feet, and I'm going to call my meters to feet function. So double click Control C, double click Control V. Okay. Now I'm going to give it some test values where I know what the output will be. So I'll look here in my specifications. And if I give it 20.0, it should give me back 65.574. And if I give it 65.0, it should give me back 213.115. So 20 and 65 will be my inputs. So I'll give it the value, the double value 20, and the double value 65. This value will of course be copied into this variable. This calculation will be made. The result will then be returned to here inside of my code, and feet will be set to that value. I then print out feet. I do the same thing again with our input of 65, and we can output our feet. Go ahead and run this code, and we can check that our function is actually not working. So note that I got the same amount for 20 as I did for my input of 65. Oh, and I see our problem here. We set meters equals to meters to feet. This is why we always test things. Alright, so let's do it correctly now, and we'll go ahead and hit run, and we'll see our correct output. Yay! Alright, so let's now create that table. Now to create our table, we can kind of think that each of these rows is doing the same thing. It has an input of feet, it puts the output of meters. It has an input of meters, it has an output of feet. So I can kind of think, hey, this would be a great for loop. I know exactly how many rows I want to go. I want to go 10 times. for my 10 rows in my table. I'll want to output my header first, of course, and then start my rows in my table inside of that for loop. I'll want to start my feet off from 1 to 10. So maybe I could have that be my for loop control, my I, 1 to 10, so 10 rows. Notice that my meters value go 20 to 65, but they count by fives. So that's also, of course, 10 rows. All right, let's do this part first, our feet to meters. So I'm going to have my for loop. I could have my int I equals 1, I less than or equal to 10, or you could have put less than 11 and equal, not minus. And then we want to increment our I by 1 on each loop. Now the reason I started it out at 1 and went to less than 10 because I'm going to use this I inside of my table. Alright, now I'm going to SYSO, control space, enter, and I'm going to go ahead and output that I variable, and then I'm going to go ahead and put a tab space because I'm thinking how I'd like my row to look. Remember what our row looks like? It'll have the feet, tab, and then the converted meters. So I have my feet, which my I variable will go 1 to 10. I got my tab, and then I'll have my feet to meters. Double click Command C, double click Command V. Alright, and I want to, of course, pass to it my feet, which I called I inside of this for loop. Alright, let's go ahead and execute that. Now before I execute it, I'm going to go ahead and comment out my other tests. It's okay if you leave these tests in here. I'm going to go ahead and run that. And you could see that yes, I got the correct output. Now note that these are integer outputs, and we saw inside of the specifications that these should be 1.0, 2.0, 3.0, and so on. Also know that these are integer outputs. And if you're a perceptive student, it might have alarmed you that, hey, we're sending an integer into this function. But it asks for a double. How is this possible, you ask? Well, Java does something cool for us, actually. It actually takes that integer and converts it to a double for us. And then it runs its function and returns to us that double. Now you can do these type conversions like this, these automatic type conversions, from int to double, because an integer is 4 bytes and a double is 8. And an integer fits inside of a double. Now, the other type of conversion from a double to an int will not work in Java, and you'll get a red underline and not be able to do something like that because a double that's 8 bytes cannot fit inside of an integer who's only 4 bytes. Alright, we successfully printed the first part of our row here. Let's print the rest. Let's think how we want our row to look. We want to tab and then put a line, then tab and put our meters starting at 20 and ending at 65. Then we'll tab and put our feet. So that's what we need to write in our program. So in my output, I can then, and I'm going to write this to a new line. And the reason I'm going to do this is so that it'll be clearer and then, of course, fit on the screen here. So I want this to all print to the same line. So to do that, you just take away the ln here, and that new line character will not be printed here, so that this output will print on the same line as this output, which is what I want for this row. Alright, I've already thought about what I want to print out. I want to print out a tab, and then a line, which I'm going to use my OR line, and then another tab, which I'll go ahead and just stick in here. I guess I could have put the other tab in there as well, actually. So tab, line, tab, and then I want to print out my amount of meters. Now, my meters start at 20, they increment by 5, and then they go to 65, so 10 rows. So I'm going to go ahead and make my meters variable outside of my loop. I want to declare him and initialize him to 20.0 outside of the loop, because if I put this line of code inside of my loop, which is a common error, it would be reinitialized on every loop iteration, and meters would be reset to 20 on every loop. So we have to declare and initialize meters outside of the loop. That's important. Alright, we'll go ahead and then print out our meters, which will be our 20.0 to 65.0. We'll then call our meters to feet function, and we'll pass to it our meters. Alright, that should just about do it. Let's go ahead and run this code. Voila, it looks pretty good. All we need now is our header. Now we don't want the header to repeat on every loop, so you have to think, hey, I got to write this line of code outside of my loop for our header. So I'll go ahead and write that up here. My SYSO control enter, our control spacebar enter. I'm going to write the word feet, and then I'm going to tab, and then I'm going to write the word meters, and then I'm going to tab. I'm going to write a line, and then I'm going to tab. Then I'm going to write the header meters, and then I'm going to tab, and then I'm going to write the word feet. Let's see what that looks like. So I'll go ahead and hit run. That looks pretty nice. I'd like to have a line underneath those. That would look great. So I can go ahead and do system out print line. And go ahead and make an underline. Actually, I think I'll use the dash character here. Oops. Well, I guess I could use the equals character too. That might look kind of cool. Alright. I'll make it a little bit longer so it looks good. I'll go ahead and run this again. See what it looks like. What did I do? Oh, I did a rookie error. Let's go ahead and run this. Alright, oh, we need to have it a little bit longer, but it looks pretty okay. Now let's format these decimals. Now, you might have thought, if you're a perceptive student, that, hey, what if we just declared that in that for loop, this guy a double? If I did that, it should print out my 1.0s and such. So I'll come over here, and what if I went ahead and made this I variable into a double? Let's see what it looks like. Hey, it looks correct. The only thing is it throws off this formatting a little bit. We can fix that up, no problem. Now, before we fix that up too, let's think why we shouldn't make this guy a double. Alright, I think inside of this program maybe it'd be okay to make this guy a double, but a lot of other programmers would say no, don't make that guy a double. Keep him in integer. Now if we keep him in integer and we still want to print out the 1.0 to 10.0, well, you could use something called typecasting. And with typecasting, it makes this guy a double for this second in time as we're printing him out. It's good to know how to typecast. To typecast, you just put in parentheses in front of that variable that you want to change the type of at this moment in time to a double. He is not changed inside of memory forever, just for this moment in the program. So Go ahead and run him, and we see, hey, it looks pretty good. Oh, except for one thing. Alright, now that our code is fixed, let's go ahead and run our code again. Look at our output. And we see that we're getting the wrong output here inside of this part of our row. Now, this is happening because meters is always the same input, so of course we're always getting the same output for our feet. We need meters to change inside the loop and increase by 5 on every loop iteration. So we're going to take our variable meters, we don't need to redeclare him in the loop, and we need to increase his value, so plus equal 5 on every loop. Go ahead and run him again, and we can see that our table is looking quite nice. Now we'd like all of these decimals to have 3 decimals for our meters and 3 decimals for our feet. So we're going to use the decimal formatter to format our meters and our feet. So we're going to declare a decimal format object. This is how we format things in Java, with classes of course. And we're going to make a new decimal format object, and we're going to give him the format that we want to have our variables in, or outputted in. Alright, so we want 3 decimal places, and we want it to show a 0 on the front if there are no values in the front. So we'll put 0, 0, 0, and what this does is there is a 0 or zeros to the right, and it's only showing 2 decimal places because that's normally how we output things. We don't show the zeros to the right. But this decimal formatter will force it to show at least 3 zeros to the right, even if there is no other digits to the right. Now I'm getting this red underline because I need to include this class. So hover over that, and the first quick fix is to import that class. Remember that that writes the import statement here at the top so that we can use this class, decimal format class. Alright, now we're going to use our new object, our decimal format object, to format our output. I just remembered that I needed to make this a little bit longer. Alright, so I'm going to format my output here. Now I'm going to show you 2 ways that you can do this to make it clear in what we're doing here. So I'm going to have Mr. df object, my decimal format object, call his first function that popped up. Eclipse is great on guessing what function I'm going to use here. He says, how about the format function that's going to format whatever's inside of the parentheses of this format function that you can call because you're a decimal format object. I say, yes, I want to use that function. And I want to pass to it what I've returned from this function, which was my double value. So I'm passing to my format function the double that's returned from this function. Isn't that a cool way to write this? Now if you're not understanding what's going on, let me write it in a little bit longer of a way. What's happening here is I'm returning the value from this function. So cut and paste. And you don't have to write it this way. I'm just writing it this way to make it clearer on what we're doing here. So remember that this function returns a double. Then I'm going to use this object with his pre-made functions. I love pre-made functions. That takes in a double and returns to me that double formatted to my specifications. Alright, I'll go ahead and hit run, and I'll see my nicely formatted output. Wow, that looks awesome. Okay, so that is how we created these 2 functions. Remember to use your debugger and figure out how these functions are working. Functions are just a nice, pretty way of making our code more organized, easier to read, and of course very reusable. Alright, Hopefully this helps show you the power of functions / methods.